Energetics. Define enthalpy change, heat energy change at constant pressure. This, so I could definitely see this being a question. It'd be very, very annoying for a lot of students because if you've never seen this before, you will not understand it. It just means that the reaction was done under standard conditions. The substances were in the standard states and the measurement, was under standard conditions. Substance standard states, measurement under standard conditions. Bond enthalpy, the energy required to break bonds. It depends on the environment it is in. Exothermic reactions give out energy, temperature increases, delta H negative. Should know this from GCSE. Definitely, yep. Temperature decreases, absorbs energy, delta H positive. Bond breaking, bond forming. Bond breaking is endothermic, delta H positive. We need energy to break bonds. And bond forming is exothermic, delta H negative, because we energy release when bonds are formed. So bond breaking, endothermic, bond forming is exothermic. Bond breaking, endothermic, bond forming, exothermic. Bonds in bonds forming, well, because bonds forming is exothermic, delta H negative, then the stronger bonds release more energy to form. Obviously. Again, get rid of that. Mean bond enthalpy, the average energy needed to break a certain type of bond over a range of compounds is positive because breaking bonds is endothermic. Perfect. And forming bonds exothermic. Formula to calculate enthalpy changes of mean bond enthalpies. You don't really need to know this. Total energy absorbed minus total energy release. You could just say energy required to break bonds minus energy released when new bonds are formed. Enthalpy change calculated using mean bond enthalpies are not exact because they use the average values, therefore less accurate than enthalpy calculated using Hess's law cycle. Standard enthalpy formation, enthalpy change 1 mole of compound is formed from its elements under states and standard conditions. Standard enthalpy of combustion, enthalpy change 1 mole of substance completely burned oxygen under standard conditions. Specific heat capacity is the amount of heat energy it takes to raise temperature 1 gram of water by 1 Kelvin. Hess's law, total enthalpy change for a reaction independent of the route taken. Use the graph to find accurate temperature change. So first thing you do is during an experiment you take beginning a couple of minutes before you start the reaction, you take samples regular intervals over a period of time. And then you plot a graph of results to find an accurate value. You draw 2 lines of best fit, 1 to the points before reaction started, 1 to the points after reaction started. You extend both lines to both past the time reaction started. Distance between 2 lines at the time reaction started is the accurate delta T. Yeah, record temperature at regular intervals a couple of minutes before your reaction. You do need to memorize that whole thing. I've really simplified it, honestly. That's how well I've simplified it. But yeah, practicals kind of come up on paper 1. Now how to use calorimetry to do this. Measure temperature solution. So we add a known volume of acid to a beaker and measure the temperature. Add known volume of alkali at regular intervals and to an incident containing measure temperature and alkali, record temperature, mixture at regular intervals, and we can find the temperature changes in the graph method.